Imagine a world without computers. No smartphones, no laptops, no internet. It's hard to picture, isn't it? Computers have become essential to our lives, but have you ever stopped to wonder what makes them tick? The answer lies in a tiny chip called the processor, the brain of every computer. It's the engine that drives all the calculations and operations. From the moment you switch on your device to the time you shut it down, the processor is constantly working, processing information at lightning speed. The story of the processor is a fascinating journey of innovation. It's a tale of brilliant minds, groundbreaking discoveries, and relentless progress. Let's dive in and explore this incredible evolution. Our story begins in the mid-20th century. Back then, computers were massive machines. They occupied entire rooms, consuming huge amounts of power. They used thousands of vacuum tubes, which looked like light bulbs, to process information. These early computers were slow and prone to errors. A single vacuum tube failure could bring the entire system down, but they were a marvel of their time, capable of performing complex calculations that were previously impossible. One such behemoth was the ENIAC, unveiled in 1946. It weighed over 30 tons and contained over 17,000 vacuum tubes. The ENIAC could perform 5,000 additions per second, a feat for its time. Despite their limitations, these early computers paved the way for the future. They sparked the imagination of scientists and engineers, inspiring them to dream of smaller, faster, and more powerful machines. The invention of the transistor in 1947 revolutionized computing. Transistors were much smaller, faster, and more reliable than vacuum tubes. They used less power and generated less heat. The arrival of transistors marked a turning point. Computers could now be built smaller and more efficiently. This led to the development of the first commercial computers like the IBM 650, which were still large but more practical than their predecessors. The transistor era also witnessed the birth of integrated circuits, or ICs. ICs combined multiple transistors and other components on a single chip. This further miniaturized computers and paved the way for the next big leap, the microprocessor. The year 1971 witnessed the birth of the microprocessor. This groundbreaking invention squeezed an entire CPU onto a single chip. The first commercially available microprocessor was the Intel 4004. The microprocessor revolutionized computing. It made computers smaller, cheaper, and more accessible to the masses. Personal computers, or PCs, were born. Companies like Apple and IBM emerged, bringing computers into homes and offices worldwide. The world was changing rapidly. People could now write documents, play games, and connect with others using computers. The microprocessor had democratized computing power. From 16 to 64 bits, a quantum leap in processing power. As technology advanced, so did the capabilities of microprocessors. One crucial development was the shift from 16-bit to 32-bit, and eventually 64-bit processing. What does this mean? Simply put, a processor's bit size determines how much data it can handle at once. A 64-bit processor can process twice as much data as a 32-bit processor in one go. This transition to 64-bit processing significantly boosted computing power. It allowed computers to run more complex software, handle larger files, and perform tasks much faster. This paved the way for demanding applications like video editing, gaming, and scientific simulations. Multi-core processors, the power of parallelism. In the early 2000s, a new innovation emerged: multi-core processors. Instead of having a single processing unit, these processors packed multiple cores onto a single chip. Imagine a team of workers collaborating on a project. Each worker contributes to the overall task, completing it much faster than a single worker could. That's essentially how multi-core processors work. Each core can handle a separate task or thread. This parallel processing capability greatly enhanced computing performance, especially for multitasking and running demanding applications. Modern marvels: speed, efficiency, and beyond. Today's processors are marvels of engineering. They pack billions of transistors on a chip the size of a postage stamp, operating at incredible speeds. Modern processors are not just about raw speed. They are also designed for energy efficiency, crucial for mobile devices and laptops. They feature sophisticated power management techniques to conserve battery life. Moreover, processors are now integrated with graphics processing units, or GPUs, dedicated processors for handling graphics-intensive tasks like gaming and video editing. This integration further enhances the capabilities of modern devices. The future of thinking machines, quantum leaps, and artificial minds. The evolution of processors is far from over. Researchers are exploring groundbreaking technologies that could revolutionize computing once again. One such frontier is quantum computing. Unlike traditional computers that use bits, quantum computers use qubits. Qubits can exist in multiple states simultaneously, allowing quantum computers to perform calculations at exponentially faster rates. Another exciting development is the rise of artificial intelligence. AI-powered chips are designed specifically for machine learning tasks. These chips can process massive datasets and learn from them, enabling advancements in areas like image recognition, natural language processing, and self-driving cars. The future of processors is brimming with possibilities. As we venture into the realms of quantum computing and AI, one can only imagine the incredible computing power that awaits us. Will these advancements lead to conscious machines as some predict? Only time will tell.